Okay, welcome everybody to our HDF clinic. It's Tuesday, it's 1 o'clock, and let's jump right into it. Let me check once more if there were any questions. No, not today. But for anybody who is here, I'm going to pause right here and ask if there are any questions. If you didn't get a chance to put it into the Google Sheet, now is the time to speak up. And if you have a question, jump in. The floor is yours. No? Okay, then we'll just continue with our usual routine. Yeah, I have not gotten an answer to that, but we'll get there. I didn't see any announcements on the forum. There was an announcement last week about the filter based on Snappy and so forth, but not this week, and that happens. On the forum, there were a few interesting things, and again, I'm kind of selective. I pick the ones that I like or I'm interested in. A lot of installation errors with HDF view and other installation errors and so forth, so maybe that's not too exciting. But someone asked a question about appending something to a compound data set, and I'm going to pick up on that in today's tips and tricks if we get to that. And yeah, there is sort of coming, especially from a database background, it is sort of tempting to think about a 1D data set that has a compound type, meaning there are multiple one or more fields that you can refer to by name, and we call this a compound data type. It's tempting to think about that as a table, and there's no harm in thinking that where it is potentially problematic is if you then, based on that, develop certain expectations how the HDF5 API should behave or does things, and that's where it gets problematic. So we will come back to that and look at some code to maybe understand where the problems sort of start. Then there was another interesting comment for people who care about documentation by Werner about we have our reference manual in Doxygen, and it's coming along. And I'm looking at it here, and his comment was specifically to, if we look at this H5Z module, for example, that there in the H5Z documentation, farther down here, there is a reference to a document in that's in PDF and external and so forth. Well, first of all, I would say at least we massage the style sheet so that you see that links to external resources are clearly marked by this sort of take me out of here icon, if you wish. But then certainly I take his point. If you click on that, in this case, it just takes you to our portal, and then there is a PDF document here, and that's a PDF document. And I completely agree that from an accessibility perspective and otherwise, that is sort of, yeah, this constant switching back and forth between different experiences, also as far as searchability goes and so forth. And his question was, well, yeah, can we have something like that ultimately in the Doxygen documentation? And the answer is clearly yes. Personally, I'm not aware of a tool that would automate that process. I mean, there are all kinds of tools that you can feed something and then it spits out something in the format that you want. But then there is always the question, how usable is that thing that you expect, or in the form that you expected, how usable is it really? And I'm not aware of any tools, But nevertheless, the content in here is important and should be part of the documentation. And in the worst case, somebody just should spend some time and resources to just port this to Doxygen. There's certainly nothing in terms of the markup or in terms of the formatting. There's nothing in here that Doxygen can't do. It's just it will take someone's time and resources. But of course, the bigger question is, this should not have happened in the first place. We should never have gone, we as HDF group should never have gone down that path and sort of created documentation in, I would go as far as in non-textual or non-text-based sources. So if you have a LaTeX file or a Markdown file, and that's all cool because it's based on ASCII text, you can version it and so forth. But where it sort of gets ugly and messy is if you use either formats that are sort of proprietary or are binary with where you can do no version control, diffing is meaningless. And so we should have never gone down the path and polluted our documentation with things like that. And that's just, we have to fess up to that and promise that we do better in the future. I can't say if that's an opinion that's shared widely in the HDF group, but personally, I think this is disastrous and should never have happened. But now it did happen. Let's deal with it, and let's deal with it. The first thing is to stop the tap and do not continue to create situations like that, but put everything into Doxygen and so forth. So, and it's not, we can't blame someone else. We can't say, oh, it's these evil people that forced us to do this. It's us acting like fools. That's what it is. And we have to be honest about that. And we are no more fools than other fools. So we make our fair share of mistakes and so forth, and we got to learn from them. And it's as simple as that. Now, I'm going to pause here and ask, are there any questions out there about HDF5? Any comments? Otherwise, we'll continue. Any questions about HDF5, your own application? Speak up. No? Okay, then I'll just continue. And I'm going to pick up on that topic that this person raised on the forum, appending to a compound data set. Okay, so on the surface, these things that we call HDF5 data set of a compound data type, or HDF5 compound datasets for short, and relational tables, they look superficially very much the same, especially if these data sets on the HDF side are one-dimensional. Just a one-dimensional array and or a vector that has rows. Let's say it's a column vector, and that has that concept of rows, and relational tables have rows too, and that all looks very similar, deceivingly similar. Now, there are several problems with that. Well, first of all, the data set on the HDF5 side could have multiple dimensions. That's a concept that's clearly not there in relational tables, because a relational table is really just a collection of rows. And not only is it just a collection of rows, the term row itself is somewhat misleading, because let's say in a vector or a matrix, a row is something that you have random access to. In a relational table, it's just a set of records. There is no such thing as a row that you have random access to. You in a table, you have typically something called a primary key or other candidate keys, which are subsets of attributes that taken together uniquely identify a given record or a row in double quotes in that table, but there is no random access to it, and it's just not anything that resembles a row in a matrix or in a vector or something like that. So other than the spelling, these rows have absolutely nothing in common. And sure, in the case of a compound data type in HDF5, there are these, you might want to call them user visible components. So typically, a compound data type has fields, and these fields have names, and you can refer to values stored in these fields, or in the case of databases, these column names would be attributes or part of the table heading, as people would say. But again, there is no such thing. And in particular, in a relational table, there is no order, since it's a set. And a set is just a collection of unique elements, and there is no order. In a given set, the only question in a mathematical sense that you can answer whether a given element or a given element is element of the set, whether a given thing is an element of that set. And that's about it. There is no concept of saying, oh, this is the first element and the second element. That's not part of the definition of a set. It's either in or not in, but there is no such thing as an order in a set. Whereas in a vector or in a matrix, the term first row, second row, or something has a well-defined meaning. Again, there's nothing like that in relational tables. Now, so that's, you could say, well, that's all philosophy and abstract and so forth. So let's get down to the nitty-gritty. So let's look at an example and come back to that question where you would like to append a row to a data set. And the fact that it's actually compound doesn't really matter. In HDF5, it works with any data type. And in the code snippet that I'm about to show you, I'll just use integers, but you can just substitute that type identifier that I use with your compound type identifier, and everything will work just the same. So the fact that it's a compound data type versus a primitive or scalar type makes no difference whatsoever to the how you append or how you add rows or records to an HDF5 data set. Okay, so let's jump right in here. The first thing, of course, we do is we create an HDF5 file, and that's just standard stuff, H5F create. We provide a file name. We want to truncate if it exists already, and then we don't use any fancy file creation or file access properties. Now, the first thing is, for argument's sake, again, in HDF5, this would work with higher dimensions, but most people would probably think about a table as this stream of records, the value of that relational variable as that stream of records. And so we will, the underlying data space in the HDF5 sense would be one-dimensional. And what we do here is basically, so we create this data space with H5S create simple. Its rank is 1, it's one-dimensional. And we, for argument's sake here, we don't know, we don't want to give it an initial size. So we say initially there are just 0 rows or records, if you wish. And then we could impose an upper limit, but as with a good relational table, we will just say, well, we don't know how many rows eventually there will be, or maybe we indefinitely want to append or change the size to an arbitrary extent. And that's why we use this constant, this predefined constant called H5S underscore unlimited to say, well, yeah, this is just a one-dimensional thing. Its current extent is 0, and it's potentially arbitrarily large. That's what this says. This is, we get a data space handle with that. And then, and this is where sort of the nitty-gritty starts. If you work with databases, then typically how you do things with databases is after you've created a table, for example, well, yeah, you would insert records, or you would do a select insert or something like that, or updates for existing records. And it is a little bit this model of, well, yeah, you can do a batch or bulk insert, but you can also do one row at a time. Of course, since SQL is such a high-level language and it's declarative rather than imperative, and what I mean by that is you just tell SQL what you want to happen. You don't tell it how to go about doing that. So when you tell your database manager, well, just insert that record, your database manager sort of takes care of thinking about, well, maybe I have already space carved out for the next 5,000 records, and I'm just going to populate what I have. Or the manager realizes, okay, I just reached the end of the current extent, and I got to allocate a new chunk of space and then put that record there. These details are all hidden from you. Whereas here, we are talking about C. We are sort of in this imperative setting where we don't have to say only, oh, I wish I could just insert another row. You have to say, this is how things have to happen. And so in HDF5, yes, I could go about acquiring new space in the file at a one element granularity, but that would be extremely wasteful, because unless that single element is very large, a megabyte or a few megabytes, allocating and freeing space is very costly. And so in HDF5, I have yet to see an example where what we call an allocation size or a chunk size of one element makes sense. So that's why in this case, I have to take control how the space allocation in the file takes place. And for this particular example here, where I just take 4-byte integers, actually allocating space or room 1,024 integers at a time is actually in practice too small. You wouldn't do it. You definitely wouldn't use one, but even 1024 is a little bit on the skimpy side. You typically, in the case of 4 bytes here per integer, you would like to see a chunk size of roughly a megabyte or more. And then today we're not going to talk about compression and so forth, which also might change the physical allocation and depending on the behavior of your compressor or decompressor, how well it deals with large or smaller chunks. So there are many other considerations, but today we keep it simple, and we are just saying, hey, whatever we do to that data set that we are about to create, as allocations take place or need to take place, just go ahead and always allocate the next 1024 elements. And we do that basically by creating a so-called dataset creation property list. And then we set this chunk size or tile size, if you wish, and we set it to 1024. And again, the rank of that chunk, of course, has to match the rank of the underlying data space, in this case, 1. Okay. And then we can go ahead and actually create that data set. So with H5D create, no big surprise here. And again, for argument's sake, I'm just using integers because I was lazy to write code for a compound data type. But if you have a compound data type, you will have some kind of a D type or some kind of handle of HID, of type HIDT, that if you put that here instead, then yeah, you will get what maybe logically appears to you as something resembling a table. So the fact that I'm using integers here changes nothing about how space will get allocated, and in particular in a moment as we see how this data set will grow or shrink in response to adjustments that we make. Okay, so we create a data set and then we are actually good to go. So because then we have the ability to adjust the extent of that data space where we started and said, well, we don't really know where to start. So we say, for argument's sake, it's empty or there's no element here, but then we don't want to impose an upper limit. To adjust that, we use this function called H5D set extend, where we basically tell the HDF5 API, this is how much data I want the user or my application to see is stored in this data set. And when I say how much, really in terms of number of elements. So when I say here 1, I really mean 1 element or 1 row or 1 record. When I say 100 here, I mean 100 rows or 100 elements. Or and this is purely logical. But of course, since we went through all that trouble here, this is what actually happens under the cover. So when I say, for example, I want this to be 1 row, well, the HDF5 library will allocate space for the first 1024 elements. And as long as my growth is less than 1024, as far as allocation goes, the HDF5 library actually doesn't have to do anything because the space is already there. All it has to do is when you write to that data set or overwrite, you update certain elements, it will just sort of scribble the values of these. If you had a compound type, the individual fields, it would just update that in the file on that chunk or on that tile, but no allocation would take place. Once you outgrow this threshold here in the one-dimensional case, so once you say, now I want this to have 1025 elements or 2048 or something like that, then the HDF5 library would pick up on that and say, well, it's time to allocate that next chunk in the file and then write or do the updates as needed. And it's really a way of amortizing, if you wish, or minimizing that cost, that by and large high cost of sort of allocating and deallocating. And so the person's question was, well, when I close the data set and then reopen the data set, can I keep on doing extend, setting extend? And so, yes, absolutely. That's sort of with this declaration that it can be as small as 0 and as large as you would like to be, and then picking that chunk size, although this is really speaks to the file internal allocation granularity, so to speak. This screate, this is sort of a logical thing, whereas this is more of a physical thing. But with that in place, yes, at any point in time, can you close that data set, close the file, later reopen the file, reopen the data set, come back, and you can actually shrink the data set. Of course, you have to be aware of that. That typically, potentially, will you will lose some of the values that fall that were previously there, but then you are saying, well, now they are not there anymore by shrinking it. Then that's your problem. So if you lose data that way, that's just too bad. But likewise in a data set, if you delete a record, then or drop an entire table, then stuff is gone. And so yeah, that's pretty much it. So set extend works. It's cumulative. When you say H5D set extend, you always specify the full extent rather than incrementally. So as this example shows here, we start with 1. If I then want 100, I really have to specify 100, which is 1 plus 99. So I don't say increase extent by 99 or something like that. Although you could write your own little function if you prefer to specify an increment rather than the total size. That's you can write a simple wrapper function to do that. But H5D set extent itself is sort of cumulative, and that's it. And then just be sure that you close all these handles to not produce any leaks, and that's really all there is to it. But the important thing is really that, especially if you come from databases, you have to take more control. So unfortunately, there is nothing like the DBMS, the database management system, that takes care of all the things. You just say, I want this to happen, and then magically things happen. Here you have to take much more control, and you have to be aware of that, although it might logically appear to you as, okay, I'm just adding one more thing, and you wouldn't sort of down in the file or at the metal, that's not how you would do it. You have to really, allocations and deallocations are expensive, and you want to be mindful, and you want to allocate ahead, not too much, but sort of you want to allocate ahead well enough so that this allocation cost is amortized, and that you don't have performance problems by making that too small, because not only is it the actual allocation or deallocation, of course, there's a whole bookkeeping infrastructure about that, because generally speaking, if you have multiple data sets, for example, in the file, and at different times you modify, for example, the extents of these different data sets, then physically in the file, if you just think about it at a byte level, the bytes from these different data sets, they will be interspersed. So, and it's part of the HDF5 infrastructure to really keep the metadata, which in turn is also interspersed with all this other stuff that you know about as a user or as an application. So, and if the granularity is just so small, if it were like one record or one row at a time, then that would lead to a tremendous bloat in the bookkeeping. And we have seen cases where the actual bookkeeping is bigger than the actual payload in terms of value data that is actually useful to an application. So that's the important thing to keep in mind, is really HDF5 one-dimensional data sets, compound or otherwise, they are not really tables, and an array is not a table. There is no concept of order in a relational table unless you say select by, and then you can sort by the value of an attribute or a set of attributes in increasing or decreasing order and so forth. But that's really a view that you create on the fly. Internally, as far as the relational model is concerned, there is no order. Whereas in a vector, there is a well-defined first element, second element, blah blah blah. So it's rather different, and yeah. Okay, I think that's about it. We have maybe 2 minutes if there's a question or comment. Anybody? No? Okay, then maybe it's going to be 2 minutes early today. What I can say is I will be here next week, and then I will be on vacation, but Elena or someone else will actually take over. So these clinics will continue, so don't go away, and we'll definitely be here next week. And then maybe it's also good to see a fresh face once in a while. Yeah, thanks for coming, and enjoy the rest of your day, and come back next week and we'll talk more. Thanks.